The James Webb Space Telescope has been doing its thing and uncovering all sorts of cosmic secrets, one after another. And guess what it stumbled upon? Something super mysterious. At first, it seems totally mind-blowing and beautiful, but once you start asking questions about it, the real mystery unfolds. In this video, we're diving into a seriously strange and mysterious phenomenon that the Webb managed to capture. Let's go! The Webb telescope has spotted a place in space 40 light-years away from Earth that scientists like to call the Hell Planet. I know it sounds intense, but it's officially known as 55 Crater. This fiery ball of mystery has been sending signals to us for more than 2 decades, and we've been scratching our heads trying to figure out why. Now, after numerous failed attempts, scientists have come up with a theory. They believe that this super-hot planet with oceans of molten lava and a core made of diamonds has volcanoes that occasionally burst open. These volcanic episodes spew out hot gas, creating a temporary atmosphere. But this atmosphere is like a shooting star. It's there for a moment, and then poof, it's gone. According to a study, this volatile atmosphere burns off, leaving the planet looking bald again. Anyway, they're saying this is the reason behind the mysterious signals. Now, the Webb is ready to point its lens at 55 Crater and see what's really going on. The telescope will analyze the planet's atmosphere, measuring pressure and temperature to check if it's as unstable as they suspect. You see, these signals are like a light show in the sky. When the planet passes in front of its star, it creates a tiny eclipse, and we get to see the light from Earth. Sometimes it's bright, and other times it disappears completely when the planet hides behind its star. It's been a cosmic mystery, and scientists have been dying to crack the code. The new theory suggests that the Hell planet's proximity to its star might be making it act like a celestial smoke machine. Huge volcanoes and thermal vents could be opening up, releasing hot carbon-rich elements into the atmosphere. But the gas gets blown away, and the whole cycle starts again. So, to prove this theory, the JWST is going to do some serious planet watching. It's going to check the pressure and temperature of the atmosphere and help scientists figure out if it's as unstable as they think. Now, let's not get too carried away. This is just a theory, and it needs some solid evidence. The Webb is like our interstellar investigator, and it's going to take its time gathering data to either confirm or bust this hypothesis wide open. It's a waiting game, but the suspense is kind of thrilling, isn't it? But the thrill isn't over yet. I find myself marveling at the incredible discoveries unveiled by the James Webb Space Telescope, particularly its recent capture of the star-forming wonderland known as Sagittarius C. This spectacle lies just around 300 light-years from the central supermassive black hole of our Milky Way, Sagittarius A*R. In this captivating image, the spotlight falls on a bustling region within an infrared dark cloud, resembling a cosmic bonfire with protostars as its embers. These newborn stars are in the throes of mass accumulation, their radiant outflows glowing brightly in the infrared spectrum. At the heart of the stellar cluster stands a colossal protostar, eclipsing our sun's mass by more than 30 times. An astronomical giant with a presence known to astronomers even before this exquisite image. The density of the surrounding cloud is so immense that it conceals stars behind it, creating a deceptive sense of emptiness in one of the most densely populated cosmic neighborhoods. Scattered like celestial voids against the starry canvas are smaller infrared dark clouds, marking the birthplaces of future stars. What adds to the intrigue is the vibrant cyan hue, highlighting extensive ionized hydrogen emissions detected by Webb's near-infrared camera on the cloud's periphery. It's as if the very edges of creation are ablaze with the vivid energy of new stars. The unexpected vastness of this emission raises eyebrows among researchers, hinting at the powerful influence of energetic photons from young, massive stars. Delving deeper into the mystery, scientists are captivated by needle-like structures within the ionized hydrogen, seemingly arranged without rhyme or reason. These enigmatic formations add an extra layer of complexity to the dynamics of this cosmic region, leaving astronomers eager to unlock their secrets through further investigation. Despite this stellar drama unfolding 25,000 light-years away, the Webb telescope's proximity to the galactic center enables a close-up view that borders on the intimate. The telescope's precision allows astronomers to discern individual stars, providing an unparalleled opportunity to study stellar formation. It's like peering into the cosmic cradle itself. This unique perspective also opens avenues for comparisons between the processes at the galactic core and those in other parts of our spiral galaxy, such as its sprawling spiral arms. One burning question under the scrutiny of astronomers is whether the central region of the Milky Way fosters the formation of massive stars more effectively than its outer reaches. It's akin to pondering whether the bustling heart of our galaxy is a celestial hotspot for the birth of these colossal luminaries compared to the more serene outskirts. Now look at this. It first appeared as a glowing blob from ground-based telescopes and then vanished completely in images from the Hubble Space Telescope. Now, the ghostly object has reappeared as a faint yet distinct galaxy in an image from the James Webb Space Telescope. Astronomers with the Cosmos Webb collaboration have identified the object as Aztec 71, a dusty star-forming galaxy, or in other words, a galaxy that's busy forming many new stars but is shrouded in a dusty veil that's hard to see through. From nearly 1 billion years after the Big Bang, these galaxies were once thought to be extremely rare in the early universe, but this discovery, plus more than a dozen additional candidates in the first half of Cosmos Webb data that have yet to be described in the scientific literature, suggests they might be 3 to 10 times as common as expected. Jed McKinney, a postdoctoral researcher at the University of Texas at Austin, said, "This thing is a real monster. Even though it looks like a little blob, it's actually forming hundreds of new stars every year. The fact that even something that extreme is barely visible in the most sensitive imaging from our newest telescope is so exciting to me. It's potentially telling us there's a whole population of galaxies that have been hiding from us. If that conclusion is confirmed, it could mean the early universe was much dustier than previously thought." The team published its findings in the Astrophysical Journal. Images of the same part of the sky in different frequencies of light show the image on the far right, representing a galaxy. The image on the far left shows no sign of this galaxy. The galaxy Aztec 71 is clearly visible in the reddest color filter of the CAM instrument on the James Webb Space Telescope, but not at all in the bluest filters. The Cosmos Webb project, the largest initial JWST research initiative co-led by Caitlin Casey, an associate professor at UT, aims to map up to 1 million galaxies from a part of the sky the size of 3 full moons. The goal, in part, is to study the earliest structures of the universe. The team of more than 50 researchers was awarded 250 hours of observing time during the James Webb Space Telescope's first year and received a first batch of data in December 2022, with more coming in through February 2024. A dusty star-forming galaxy is hard to see in optical light because much of the light from its stars is absorbed by a veil of dust and then re-emitted at redder or longer wavelengths. Before JWST, astronomers sometimes referred to them as Hubble dark galaxies in reference to the previously most sensitive space telescope. Until now, the only way we've been able to see galaxies in the early universe is from an optical perspective with Hubble. McKinney said, "That means our understanding of the history of galaxy evolution is biased because we're only seeing the unobscured, less dusty galaxies. This galaxy, Aztec 71, was first detected as an indistinct blob of dust emission by a camera on the James Clerk Maxwell Telescope in Hawaii that sees in wavelengths between far infrared and microwave. The Cosmos Webb team next spotted the object in data collected by another team using the ALMA telescope in Chile, which has higher spatial resolution and can see in infrared. That allowed them to narrow down the location of the source. When they looked in the Webb data in the infrared at a wavelength of 4.44 microns, they found a faint galaxy in exactly the same place. In shorter wavelengths of light, below 2.7 microns, it was invisible. Now, the team is working to uncover more of these faint galaxies from the James Webb Space Telescope. McKinney said, "With Webb, we can study for the first time the optical and infrared properties of this heavily dust-obscured, hidden population of galaxies because it's so sensitive that not only can it stare back into the farthest reaches of the universe, but it can also pierce the thickest of dusty veils." The team estimates that the galaxy is being viewed at a redshift of about 6, which translates to about 900 million years after the Big Bang. Now armed with the incredible James Webb Space Telescope, scientists recently stumbled upon 6 new galaxies. But these galaxies shouldn't exist, at least not according to our current understanding of the universe. The telescope detected these celestial anomalies just 300 million years after the Big Bang. So, what are these mysterious galaxies, and how did they manage to elude our cosmic grasp for so long? These newly discovered galaxies have been fittingly dubbed universe breakers by scientists, signaling a challenge to established cosmological theories. They emerge from the cosmic dawn, 500 to 700 million years after the Big Bang, defying our expectations of finding small, young, and blue galaxies. But how did the James Webb Space Telescope make these groundbreaking discoveries? Well, it all comes down to the telescope's unique capabilities. Its ability to peer into the infrared spectrum allows it to see through cosmic dust clouds that would otherwise obscure our vision. This means it can observe objects that emit faint infrared light, revealing celestial wonders that were previously hidden from our view. However, the universe breakers defy this expectation, revealing a cosmos where massive galaxies, akin to our own Milky Way, existed much earlier than anticipated. So, what are the implications of finding galaxies that should not exist? For one, it forces scientists to reevaluate their models of galaxy formation during the universe's infancy. The known mass and stars during this period, according to the universe breakers, is up to 100 times greater than previously thought. So what other cosmic surprises await us? How many more anomalies lie hidden in the depths of space, defying our expectations and challenging the limits of our knowledge? The James Webb Space Telescope urges us to question, adapt, and expand our understanding of the universe. The seemingly insignificant reddish dots that adorn the canvas of space reveal astonishing tales of distant galaxies that defy our existing understanding. One of the celestial wonders that captivates our attention is GNZ 11, a galaxy that holds the record as the most distant ever observed. Can you fathom the fact that the light reaching us from GNZ 11 embarked on its journey when the universe was just a mere 330 million years old? Despite its early formation, GNZ 11 challenges our perceptions by presenting itself as surprisingly compact. Have galaxies been forming earlier than we previously believed, reshaping our understanding of their size and mass? Venturing further, we encounter GZ 10, a galaxy situated a staggering 13.3 billion light-years away. This distant marvel outshines theoretical predictions by nearly 100 times, suggesting a frenzy of star formation beyond what we envisioned. How do these accelerated star formation rates in massive galaxies alter our perspective on the efficiency of star formation processes in the early universe? Moving closer to our cosmic neighborhood, we find GNZ 9, situated about 13 billion light-years from Earth. This galaxy showcases an abundance of heavy elements like oxygen, carbon, and nitrogen, essential ingredients for life as we know it. The presence of these elements hints at star formation and supernova explosions transpiring in the early universe. Not far from GNZ 9, we encounter GNZ 8, challenging our existing models with its remarkably structured disks, previously considered improbable in the turbulent early universe. Now, these disks raise questions about when disk formation truly began. As we navigate the cosmic realms, JZ7 captures our attention with its exceptional richness in dust. This abundance of dust particles suggests the early stages of planetary system formation. Finally, GNZ6 reveals a surprising redshift, hinting at a potential location in a region of the universe with a slightly slower expansion rate. These 6 galaxies discovered by the James Webb Space Telescope mark a profound leap in our understanding of the early universe. But what do these revelations mean for our existing cosmological models? The early formation of galaxies challenges our established views, suggesting that the cosmic symphony of galaxies might have commenced much earlier than we once thought. The structured disks observed in galaxies like GNZ shake the foundations of our galaxy evolution models. The heavy elements discovered in galaxies such as GNZ 9 unravel a tale of rapid chemical evolution in the early universe. The forging of these elements through supernova explosions challenges our previous notions of when these cosmic fireworks first ignited. Now, it's time for the mysterious phenomenon. A recent revelation by the James Webb Space Telescope has unveiled a cosmic anomaly, a record-breaking, free-floating brown dwarf, along with 2 other celestial entities known as failed stars. This intriguing discovery occurred within the youthful confines of the IC 348 star cluster, a mere 1,000 light-years away from our home planet. As Webb turned its eye toward the heart of the IC 348 cluster, it captured a mesmerizing image adorned with pink and purple hues, showcasing the celestial dance of gaseous nebulae and the faint glow of numerous stars. Amidst this, the telescope identified 3 brown dwarfs, each with its unique characteristics, challenging our understanding of stellar birth and the fine line that separates planets from stars. The standout among these cosmic misfits is a brown dwarf that's not gravitationally bound to any star, a true wanderer in the universe, straying far from the warmth of a stellar parent. This particular brown dwarf represents a new class of celestial oddities, a group of enigmatic objects that eluded detection until Webb's powerful lenses unlocked their secrets. Though often labeled as failed stars due to their inability to sustain nuclear fusion, brown dwarfs hold a curious position in the cosmic hierarchy. They are too massive to be considered planets but too small to qualify as true stars, thus inhabiting a strange middle ground in the realm of astronomical classification. The discovery of these wandering brown dwarfs in the IC 348 star cluster is nothing short of fascinating. Webb's keen infrared vision has revealed these enigmatic objects that don't fit neatly into our previous understanding of stellar evolution. These brown dwarfs are akin to cosmic nomads, drifting through space without the gravitational anchor of a parent star. They stand as celestial anomalies, neither stars nor planets, but something in between. Despite their failure to ignite nuclear fusion like true stars, these objects still emit heat, making them detectable through infrared observations. The exact origins of these brown dwarfs remain unclear, but their presence raises intriguing questions about how they form and evolve. Are they rogue remnants of star formation, or do they represent an entirely different class of celestial objects that have yet to be fully understood? Webb's observations are revealing a rich tapestry of unexplored possibilities, shedding light on the processes that give rise to objects that don't conform to traditional stellar definitions. As astronomers continue to study these cosmic wanderers, they may uncover new insights into the complex interplay between gravity, gas, and dust that shapes the early stages of star and planet formation. The discovery not only challenges our definitions of celestial bodies, but also hints at the possibility of new, unexpected phenomena in the vast and ever-expanding universe.